Today we're going to talk about sequencing transformations to prove whether the transformed shapes are congruent or similar. A sequence of transformations proves whether shapes are congruent or similar. A congruent statement lists the sequence of transformations that bring one shape to another, proving that they are congruent. A similarity statement lists the sequence of transformations that bring one shape to another, proving that they are similar. So this is a lot of work, and you have to really pay attention to some small details in order to figure out whether a shape was rotated, reflected, translated, or dilated to get a second shape. Remember that the only time the dilation happens is if the shape is smaller or larger than the original shape. Otherwise, all the other transformations are the only things that could have happened. So if you have congruent shapes, the only types of transformations that could have occurred are translations, rotations, and reflections. So let's take a look at number 1, do it together. So here we're going to start by graphing math. So we have -3, 9. So we're going to go left 3 and up 9, which is all the way at the top, and make sure you label it M. Then -5, 5, so left 5 and up 5, and label that A. T is -3, 1, so left 3 and up 1. And last H is -1, 5, so left 1 and up 5. And we get a rhombus. Use your straight edge and connect the sides, M to A to T, T to H, and H back to M. Then we're going to graph our second shape as well, which notice there are 2 primes, so that's our hint that 2 things have occurred. So we're going to start with M double prime is 0, -6. So staying at 0 and going down 6. A double prime is 2, -2, so right 2, down 2. T double prime is 0, 2, so stay at 0 and go up 2. And H double prime is -2, -2, so left 2, down 2. Take your straight edge and connect your points neatly. So right away you should notice that the 2 shapes are exactly the same size, so a dilation definitely did not occur, but it's our job now to figure out what types of transformations did occur. So if you take a look at the letters, that's going to help you out big time. So notice in our first shape, the M is all the way up at the top. So right up here. Oh, excuse me. Didn't mean to do that. Just wanted to point. Let's see if it'll let me. So right here is our M. Oh. Okay, and then in the lower shape, our M is all the way at the bottom. Okay, so that is a hint that it was either rotated or reflected. So we also have to look at the other letters, because if this was just a reflection, all the other points would just be upside down as well. So M is upside down, T is upside down, but now we look at the H and the A. They are upside down as well, but reversed. So in my top shape, I have A on the left-hand side and H on the right-hand side. But on my bottom shape, I have H on the left-hand side and A on the right-hand side. So that is our hint that this isn't just a reflection over the x-axis. It is a rotation of 180 degrees. So we're going to start by rotating our original figure 180 degrees. And hopefully you remember that the rule to do that is to change all the signs in the original figure. Not sure why that one does not want to erase. Come on, work with me. There we go. All right, so we're going to take our original math and we're going to rotate it 180 degrees in order to get our letters lined up the way we want them. So 180, we change both signs. So M prime is going to be 3, -9. A prime is going to be 5, -5. T prime is going to be 3, -1. And H prime is going to be 1, -5. So I'm going to go ahead and graph that. M prime is at 3, -9, so that's right 3 and down 9, all the way at the bottom. A prime is at 5, -5, right 5 and down 5. A prime. T prime is at 3, -1, so right 3 down 1. And then H prime is at 1, -5, so right 1 down 5. And I can go ahead and draw my shape neatly. And now notice I have all my letters in the right direction. So I have T at the top, both A's on the right-hand side, both M's on the bottom, both H's on the left-hand side. So now I just have to figure out the second transformation that's been done. And it should be obvious to you that to take my red figure and move it on top of the double prime blue figure, it's just a slide or a shift, which means that we have to translate it. So lastly, we're going to do a translation. In the direction of, well, let's see, we have to count. So the translation is going to be left 3 and up 3. So I could write translation left 3 and up 3, which if you remember is that x minus 3, y plus 3. So we're done. By doing that last translation, it has moved it into the right direction. We've stated the two things that have occurred to get math to math double prime. So now from here, we can talk about, well, would it matter which transformation was done first? It wouldn't at all. We could have done the translation first if we had translated, instead of going left 3 and up 3, we could have translated right 3 and down 3. That would have matched those up and then done the 180-degree rotation to get the letters in the right spot. So are the shapes congruent or similar? It should be obvious that they are similar. Or sorry, not similar. They are congruent because they are the same shape. They are the same shape and size. You could also add, if you wanted, that a dilation did not occur, and the dilation is the only transformation that would change the shape and size. Okay, so let's take a look at the second example. I'm going to go ahead and do all three with you today. So turning the page, we're going to start by graphing love. So L is at -4, -8. So left 4 and down 8. O is at -6, -1, so left 6 and down 1. V is at -4, -3, so left 4 and down 3. And E is at -2, -1, so left 2 and down 1. So you get a heart-looking type shape, hence love. And then we're going to go ahead and graph love double prime, again noting that it's a double prime, which tells us that two things occurred. So 8, 4 is right 8 and up 4. O double prime is at 1, 6, so right 1 and up 6. V double prime is at 3, 4, so right 3 and up 4. And E double prime is at 1, 2, so right 1 and up 2. Connect your points. Showing exactly the same figure, just in a different position, exactly the same size and shape, which proves to us that this is going to be a congruent statement as well. So now we have to determine the sequence of the transformations performed to love to get love double prime. So again, it could be two different things, but hopefully you're seeing that obviously we need a 90-degree rotation here in order to get it turned on its side. So let's start with the 90-degree rotation. If we do a 90-degree clockwise rotation, it would wind up in the second quadrant where we know the signs are negative, positive. So we use that rule for 90-degree rotations where we switch the x and the y and then apply the new signs. So L prime is going to be -8, +4. O prime is going to be -1, +6. Switch and apply the new signs. V prime is going to be -3, +4. And E prime is going to be -1, +2. So we can go ahead and graph those. -8, +4 would be left 8, up 4. L prime. O prime is -1, +6, so left 1, up 6. V prime is -3, +4, so left 3 and up 4. And E prime is -1, 2, so left 1 and up 2. Connect your points. And now we only have one more transformation that has to be done, and hopefully you see that it is obviously a reflection over the y-axis. So what did we do first? We rotated 90 degrees clockwise. And then we reflected over the x-axis. Over the y-axis. And that proves, because we only did a rotation and a reflection, that these are congruent, not similar. Again, the only type of transformation that would create a similar shape is a dilation, because that is the only transformation that changes the size of the shape. Okay, so we've got that one all done. That was a simple one. We could have, just like I said before, done it the opposite way. We could have reflected over the x-axis and then rotated 90 degrees clockwise. We could have reflected over the y-axis and then rotated 90 degrees counterclockwise. All of those would work as long as it's some kind of 90-degree rotation and reflection. All right, so the next one is going to be a little bit more challenging. Because now notice we have 3 primes. So 3 things have happened, not just 2 things. So let's go ahead and start by graphing TRI. T is -4, 0. So we start at -4, or we go left 4 and stay at 0. R is -8, -6. So we go left 8 and down 6. And I is 0, -6, so we stay at 0 and go down 6. Draw your lines neatly, use your straight edge. And we have a triangle. So now we're going to graph our triple prime tri. So T triple prime is 0, 2. So now we go 0 and up 2. R triple prime is 3, 4. So left or right 3 and up 4. And I is 3, 0. So right 3 and stay at 0. So right away, you should be noticing that my triangle is no longer congruent. It's definitely smaller, which gives us the hint that a dilation has occurred. So I would always start with the dilation when you have a dilation. So in this case, if you look at this very closely, you can notice that the R to I prime, oh, I don't know why I put prime signs there. These shouldn't be primes. R to I is 1, 2, 3, 4, 5, 6, 7, 8 units long, where I triple prime to R triple prime is only 4 units long. Remember, when you do the scale factor, it's always prime over original. So my scale factor would be 4 over 8, which simplifies to 1/2. So dilation by 1/2 is the first thing we want to do. So let's go ahead and cut all of our original coordinates in half. So t prime is going to be -2, 0. R prime is going to be, cut it in half, -4, -3. And I prime is going to be 0, -3, cutting both of those in half. So let's go ahead and graph that. We get -2, 0 is left 2, stay at 0. R prime, -4, 3 is left 4, down 3. And I prime, 0, -3, stay at 0, down 3. So now we have a smaller triangle that's congruent to the triple prime figure. So we have one more in-between stage that we have to figure out. So noticing right away, I have something that has definitely been turned 90 degrees. So I could do the 90-degree turn first, but I can also do a reflection first. So it would really be up to you to decide which one you want to do. I think 90-degree rotations are a little bit harder. So if I wasn't doing it by myself, I'd probably do a reflection first. But since I'm helping you guys out, let's go ahead and do that 90-degree rotation. And let's do a 90-degree rotation counterclockwise this time. So if we turn our green figure 90 degrees counterclockwise, it's going to land in the fourth quadrant, which is positive, negative. And applying that rule, we're going to switch the coordinates and apply positive, negative. So -2, 0 is going to become 0, -2. R double prime, -4, -3 is going to become 3, -4. And I double prime, 0, -3 is going to change to 3, 0. Go ahead and graph that. 0, -2 is now our t triple prime, or double prime rather. R double prime is 3, -4, so write 3, down 4. And then I double prime is 3, 0, so write 3, stay at 0. So I double prime winds up being right on top of I triple prime. Draw your shape. So we did a 90-degree counterclockwise rotation. And then last, we have to figure out if it's a reflection over the x-axis the way we did it, or a y-axis. So if you take a look at those points really closely, to get R double prime up to R triple prime, we'd have to reflect over the x-axis to do that. So lastly, we would write reflect over the x-axis. So as I said before, I could have rotated 90 degrees clockwise and then reflected over the y-axis. I could have reflected over the x-axis and then rotated 90 degrees clockwise. I could have reflected over the y-axis and then rotated 90 degrees counterclockwise. Any combination of dilation by a half, 90-degree rotation, and reflection would have had these match up. And again, because the shapes are not exactly the same size, a dilation occurred, we no longer have congruent shapes, we have similar shapes. And that is mainly because of the dilation. The dilation is what causes the size to change and creates a similar shape, not a congruent shape. All right, so you guys can go ahead now and answer the exit tickets and then move on to your homework. Tomorrow you will be a lot more independent with these.